afternoon, everybody. My name is David Schainker. This is my talk about my first ever NERVS project, which is a photo bioreactor. I'll tell you a little bit about myself. I'll overview what we're going to be talking about, and then dig into the build and what I learned doing this, since it's definitely my first time working with NERVS. So right now I'm a computer scientist at Adobe Typekit. My first Erlang Elixir experience was in 2015 for a project that also involved Phoenix. And I haven't touched embedded programming since my 20s, which makes me sound really old, but that was really only a few years ago. And that project was cool. It was an IoT project that also used some Arduino sensors. And it was a really difficult, crazy project, partly because it was my first embedded project, but also because the process was much different and the tooling was much different. I would say I'm more mad scientist than biologist. My training is in software engineering, but this just seemed like an interesting thing to try out, so that's what I did. Does anyone know what time it is? Anybody?
1:43.
It's 1:43? NERVS time? No? Nobody? It's NERVS time? If you hear what time is it with NERVS, you gotta say it's NERVS time. This is a big deal. What time is it? Yes, okay. So, I'll talk a little bit about how I got started with this, how I got started with NERVS. We'll put it together. We'll talk about what it was, what I learned, things that I'm gonna do better next time, and what the future looks like. So, first, in the background, there's a little bit of terminology I want to go over. A photo bioreactor. Does anybody know what that is? Cool. This is a really fancy way to say growing something in a box with artificial light. That's all it is. There's another term called VOCs. These are volatile organic compounds. They are things that are in polluted air that react with your body. Finally, we talk about the concentration of these pollutants using terms like parts per million, particles of size 2.5 microns, so PM 2.5, PM 10 is 10 micron particles. And then we'll also use the term optical density a bit in this talk, and I'll go over that and what that is later on. So I used to live in Taipei. I just moved back here. On a good day in Taipei, like the photo on the left, the AQI is around 30. For comparison, today in Seattle, it's in the 20s. So this is like really nice, clean air. In bad days in Taipei, the AQI, like the photo on the right, is 200. To put this in perspective, by the way, like places like New Delhi or Beijing, the AQI can reach 500, and it's like literally deadly. Days like this, where it's 200, have the official name unhealthy. So there's a practical reason for this. There's a science experiment from the NIH that's really great that shows that if you put people in an area with clean air, we're very good at problem solving and doing normal human things. If you put people in an environment with very bad air, we actually have real problems thinking clearly. So I think there's an opportunity here for us to use NERVS and Elixir to make the world both cleaner and smarter. At the very least, we can maybe change some hearts and minds here, and I think that's a pretty good start. So there's some houseplants you can use to clean air. This is a really cool thing I learned. There's a TED Talk from a guy named Kamal Meadle. He put plants in a building in New Delhi because he was becoming allergic to the air. And if you're inside his building that's full of these plants, you actually can just become healthier by just breathing inside the building. These plants are great to put in your home because they can also replace the air breathed by humans. So if you have 4 areca palms that are about shoulder height, that can filter the air of one human. If you use mother-in-law's tongue, you need about 6 of them. They grow to about maybe thigh height. And that's another plant that can clean the air. And then the money plant, you need about 4 of them at shoulder height, and you can clean the air with them. So being a beginner gardener a couple years ago, and finding out about this, we said, hey, let's buy an areca palm and put it in the apartment. but we're kind of lazy programmers. Like maybe we don't want a lot of plants, so let's just get one big plant. So this is not 3 shoulder height plants, but this is 1 triple shoulder height plant. And sure enough, it does its job very well. It helps clean up the air in the apartment on bad days. There's a very slippery slope between purchasing your first plant and winding up with lots of plants and a garden, and then the next thing you know, the animals in the garden are attacking you, and it's very tricky. So with this one plant, we got to many plants, and then I'm like, okay, let's make this easier and simpler. Maybe there's something else. So I started reading about algae. Chlorella vulgaris is a single-celled freshwater algae that grows everywhere. It's a really, really ancient organism. It evolved something like 500 million to 2 billion years ago. It's everywhere on the planet. It's in lakes, it's in rivers, it's in the soil. It's really great at staying alive, and it happens to be more powerful per unit mass at filtering air than most houseplants. So it's easy to grow, it's hard to kill, and if you are growing it in like a tank with water, every once in a while you will need to throw out that water or do something with it. The waste is safe, so we're not like creating trash from this experiment. And as I later read, the waste can actually make you money. Globally, the industry for growing algae like this and selling it for things like animal protein, for fertilizers, for all kinds of like products, it's like a $5 billion industry. So maybe there's even an opportunity with this project to like make money on the side. I don't know if it's possible. So to start this experiment, we need some goals. So the first thing is we want to try to harvest as often as possible, because then we're proving to ourselves that we're growing as fast as we can. We want to try to see if maybe we can physically measure this thing in action. It would be really great to see that and be able to say, hey, look, this thing in my room right now is actually making oxygen and cleaning the air. And if we're really lucky, maybe we can make some money. So with this, we got to get started with nerves. This was a pretty straightforward process. You need to pick your hardware. You need to figure out what sensors you want to support. You need to start building something. So I wanted to use a Raspberry Pi Model 3 B+, because it's really well supported by nerves. And by well supported, I mean like everything works out of the box. There's a library called Nerves Init Gadget, which then gives you a lot of the other batteries that you need. So for me, I had to grow this thing in a dark room. I obviously can't leave my computer there and like work in a dark room, even though that's, I guess, kind of what I do every day, isn't it? So I thought it'd be great to put this thing on the local network, work from my office, push code updates to it remotely. So if your needs are different, one thing that I think is really important for getting started is to get a serial cable for the Raspberry Pi. This will let you actually plug the device in over USB, read the serial output, give you a terminal, and you can actually hack away directly on the device and on your running application without a lot of trouble at all. So I really recommend to anybody getting started, get a serial cable. They're like a few bucks. It's a huge productivity boost because you're not having to plug your Pi into a TV and then plug in a keyboard and be in a setup that might not be super comfortable. So the hardware support I chose was something called GrovePI. This is a hardware platform made by a company called Dexter Industries. It gives you sensors that you can plug in over a standard hardware interface, and they make like over 100 sensors. So there's tons of selection, there's tons of cool things you can do, and it just so happens that a member of the community here by the name of Amos King, is Amos here? Maybe? Maybe? Okay. So Amos wrote a library for GrovePI that communicates with the GrovePI hat, and it lets you support all kinds of stuff. So the kind of high-level internals of the GrovePI library is that these types of electronics often speak special protocols. So they'll send binary blobs to your device, or you will send them messages to get information. So the kind of core of GrovePI is using pattern matching to parse out messages so that you can read sensor data. This is a great use case for Elixir. It works really great. It makes it easy to send messages to new sensors you haven't written code for, get messages back, figure out what's going on. The debugging process is really straightforward. Another thing that's really cool about the GrovePI library that's been made is that it works without hardware. So you don't need to necessarily invest tons of money to just get the thing plugged in so you can mess around with it. The test suite supports hardware-less tests, and it was a really nice thing to be able to work on it and play with it, even though I didn't have stuff on me. It was all in the mail. Finally, when you're writing sensor code, supervision trees are really useful. Wrap your sensors in a supervised process, and you can let them crash and do weird things, and they'll just restart, go back to what they were doing, and you don't have to threaten the whole health of your application because you're trying to run buggy code on a new sensor that you haven't used before. So, back to algae. Easy to grow, hard to kill. Give it a good pH range, so the acidity of the water needs to be a certain amount. Keep it above room temperature. Don't give it 24/7 light. So there's a little bit of complication in there where you need to make sure that the light is around 20 hours a day. If you give it 24/7 light, it will grow slower. Finally, the cells are heavier than water, so they sink. So it's also important to do something to kind of stir the water so that you can make sure that they don't settle and, I guess, crush each other. These are really small organisms, but I guess they can crush each other. And finally, you know it's time to harvest or make changes to the system because the water will turn a very deep green and it will start absorbing more light. So there's a really easy signal to know if things are working or not, or when it's time to do stuff. So let's try and put this together a little bit. This is a picture of the setup. We've got solid state relays to control the lighting and the air pump. The air pump is what I'm using to not only stir the water, but also feed just CO2 from the air into the system. So there's a little bit of nutrients to kind of get the incubation started, but overall it's pretty much just, you feed it air and it just grows, which is pretty cool. There is a temperature sensor, which was my stretch goal for the project. It's not fully supported yet because it does kind of exotic things. This temperature sensor happens to tell you the ambient room temperature as well as the temperature of something that you point it at. And it has a range of like a couple inches. So rather than trying to like stick a temperature sensor into the water and mess around with that, I thought this would be a cool way to measure the temperature without having to do something really invasive with the system. There's an infrared sensor, which is used to monitor the opacity of the water. So it sends out infrared light, and it has a separate piece that detects whether that light is being reflected. And so if the light stops being reflected because the water's too dark, then that's probably a good time to do something. This sensor can be calibrated by hand mechanically. There's like a potentiometer on it. You can't actually software program it to be calibrated for certain values, but I thought this was a really great start, and it was a really cool sensor to use. And then I put 2 oxygen sensors. So the top of the tank is covered with saran wrap to make kind of an airtight seal, and there's a small hole with one of the sensors monitoring the output of air, and then the other sensor is just sitting in the room to monitor the ambient air. So while I was researching this, there was all kinds of great documentation on how to use really expensive, like high-end equipment to do this, and I just don't have that kind of money. I found a company called Algae Research Supply that supplied some documentation on a much simpler way to grow algae. They sent me a kit halfway around the world. They were really cool on getting me connected with documentation and how to grow the algae and manage the state of the system. So we start out pretty simply. We're gonna take a small amount of algae that's already in solution, give it some nutrients, add some water every day and some culture every day, and then we enter the incubate phase, which is just the longest phase where things just sit around. When we've been incubating and the water becomes opaque, we can check whether there's enough volume in the tank to harvest, or if we just need to add more water, and then the process just repeats itself. So it's not a very complicated state machine, but there is a state machine that you can build with this setup. So the way I did that was I used a struct to represent the sensor data that's coming in. GrovePI lets you implement triggers that basically notify processes that changes happen. So it's really easy to just read data, update it, and then send it to maybe a state machine that's powered by reducers to process the data and do the next thing that you need to do. All of these sensors are wrapped in processes, as I mentioned a moment ago. So if things crash, if the sensors give you weird data, it's very, you don't have to worry about things going offline. It actually was really robust. I was really surprised that I had not a lot of problems. And so put this together with the NERVS project components and the GrovePI library, and you can totally build a photo bioreactor on your own. It's really cool. I did not expect to get a real result out of doing this so quickly. So let's talk about how did this go? What were my expectations? Were they met? Were they not met? I wanted to maximize the frequency of harvesting the algae. Turns out it's really slow. Algae grows really slow, even with ideal conditions. I harvested my first set of algae after about 3 or 4 weeks, and it takes a few days for things to go back to where they were. So I'm not harvesting algae every day. I'm not swimming in algae and swimming in money. We're not there yet. Measuring a change in oxygen concentration was really difficult because I think right now the system works, but it's not producing enough oxygen to be detected because my sensors are not really fancy sensors. I also had one problem with one of the sensors. It would read that there was 2 to 5% less oxygen in the air than the other sensor, even when they were just sitting next to each other. This sounds like a small problem to have, but normal air is about 21% oxygen, and anything below 19.5% will kill a human. So I'm pretty positive that one of those sensors was just full of lies, and it was always giving me consistently the wrong values. And so I had to kind of fudge around with the code to get it to recalibrate a little bit, but I would just, when you get that, just replace the sensor. If you're working with cheap sensors, it's better to try to work with a cheap sensor than try to give it a crutch and hobbles along and maybe blows up, who knows. And then of course, as I mentioned, since harvesting is really slow, we're not making any money yet. This is a very slow but steady process. On my way to the conference, actually, this idea was further validated. There was someone that was talking to VCs at the airport about an algae growing business that they wanted to fund. This really happened. And she says on the phone, yeah, we really wanted to fund this algae business, but it's just not scalable. Everything grows too slowly. They can't make money fast enough. And I was like, wow, that's really funny. I figured that out this summer because I sat around watching algae grow. So how was the experience? Working with NERVS, working with Elixir, doing this project. It was actually pretty good. Sensors are finicky. I knew that going in, that I had that happen again. The fact that I had OTB and supervision trees to help restart sensor processes was super helpful. When I was doing this with Arduino, it was like your device could just go offline because there was some bad data read and you didn't handle bad messaging well enough. It was a really, really brutal process. So be aware the sensors will be finicky. If you have money to spend, you can get way better ones. And no matter what happens, it's easy to handle things when they give you weird data. My reactor was not super well controlled. I don't feel like my results were really good enough. So I either need to build something smaller that's more tightly controlled, or maybe grow it bigger so that it's really obvious when there's a change happening and it's detectable by my really low-end sensors. So again, this was a huge improvement over the last time I did this. I really recommend people use Nerves for doing embedded programming now. It was a real joy to do this project. I had tons of fun with it. And even if you're doing something like watching algae grow slowly or monitoring your garden or something, you can just let the system sit there and it'll do its thing and give you data, and you can just build on top of it. It's really fun. The last thing, this comment, fish without fish. Algae has a special smell, and so I really recommend you do this in a well-ventilated room or outside. I was lucky, I had friends, and I was at places where I could do this and it was in a well-ventilated area, but it's a very tricky thing to control this because it's something that this thing naturally does. There are papers that say you can change the smell by changing the nutrients you feed it, so maybe there's something there. Hopefully there's other ways to improve it. I did reach out to Kamal Meadle from the TED Talk I mentioned at the beginning, and he had a really great comment for me. He says, you know, mother-in-law's tongue is really great at filtering smells. Maybe you should try using that with this project. And so here I am in my effort to like automate cleaning air without plants and with technology, and he's like, seriously, just use plants. Like this is, you know, you can kind of hear the brutality in the tone of his email, but it's true. I didn't have to do it this way. This was just a mad science experiment I thought would be really fun. And so let's talk about how to make this better. The first thing I want to do is give it a web interface and use Phoenix to talk to it. Before I had sensors fully supported, I'm inputting data by hand through a terminal. It'd be cool if I could just get up a web interface and say like the pH is this today, the temperature is this today. That would be great. Then I could build a dashboard, I could get trends, I could monitor changes, I could start even alerting if something goes wrong. And that would be a really nice feature to add. Secondly, I didn't use a lot of tests. I didn't use property-based testing. I definitely want to do that next time around because this is ElixirConf and you should use as many of the features in the language as you can. Finally, if I can support more precise sensors, that'd be great. The GrovePI hardware interface is an open standard and it's not a super complicated standard, so you could definitely hook up other sensors to feed it data and read from them and have results. And of course, finally, I probably just should add plants if I want the smells to go away. And then that just brings us full circle. So I have plants, I have algae, everything's happy, and maybe I can sell the algae and make some money to pay for more plants. That would be pretty great. This talk would not be possible without a lot of people helping me. So the first thank you is to the Nerves team. Connor, Frank, Greg, and Justin. They were super attentive on Slack. They were attentive on GitHub. They answered all kinds of questions I had. It was really cool to have that experience with the developers themselves. So huge thanks to them because Nerves effort is big and there's so many moving parts and so much of it just works arguably like quite flawlessly, even if there's some stuff under the hood. It worked great. I also want to thank Algae Research Supply. They supplied me with my algae kit. They supplied me with great documentation for getting started. That was really useful and helpful of them. The guy that runs it named Matthew. Reach out to them anytime. He's really receptive to answering questions. He loves algae. It's really cool that he was just so excited I called him out of the blue and then just spent hours on the phone with me, like helping me get started doing this. Then I want to thank Amos King. He accepted PRs from me. Amos is in the room in the back over there. He accepted PRs from me for new sensor code. So big thanks to him for keeping his project maintained and making the test suite so awesome that I don't need hardware to use it. That was really cool. And then my last thank you is to Kamal Meadle because he answered questions from India and just spoke to this random guy doing a mad science project. And he was very kind and courteous with answering questions. So that's it. You can find me on social media. Any questions that people have? I think we have one over here. Mike is coming your way.
Thank you for the talk. got a two-part question.
Okay.
One is, what does the harvest process look like when you actually have that algae? And then second, what did you personally do with your harvest?
Cool, so that's a great question. The harvest process with algae, if let's say you're trying to use it for, let's say making like animal feed or biofuel, it's basically you're gonna take a big bucket of water, scoop some out, and then run it through a sieve and a filter to get the biomass out. And then you can take the biomass and do what you want with it. For example, in the nutritional supplement industry, they dry it and compress it into pills. And that's a huge thing, especially in Taiwan and Japan. If you are doing animal feed, it can just get mixed in. For me personally, I was just trying to see if I could make this work, so I just took my waste and I dumped it in the garden, and it acts as a great fertilizer. There's already algae in the soil, so this has no like negative impact on anything you're doing. Any other questions?
Other than GrovePI, are there other kind of similar boards, or do you find in your research that this is the best one or the only one?
Yeah, that's a great question. So depending on how many sensors you need, you probably don't even need a GrovePI. You can just get a breadboard and some wires and plug stuff in and it works. The reason why I bought the GrovePI was I was starting to support more sensors than I could breadboard for. And that was really my main driver for doing it. The GrovePI is not cheap, I'll be honest about that, but for me, I needed convenience because I'm not good at electronics. So that was my reason for buying it. Other boards include doing Arduino. The NERVS project supports BeagleBone Black and other Raspberry Pi models. So you don't have to use a Raspberry Pi 3. There are other hats for the Raspberry Pi, which I don't know if they have Elixir support, but they are out there. So you can support other special types of sensors and things, and then just write code for it with NERVS and Elixir. Any other questions?
So you're dealing with algae growing in water and trying to circulate the air over it. How do you deal with the humidity coming off of that aside from just running a dehumidifier?
So for me, I was running it in a ventilated room that was a bathroom that a friend wasn't using in their apartment. So it was just being vented. I was also in Taiwan doing this, and it was already very humid, so I couldn't really tell the difference. But if you're doing this in a dry climate like out here, you'll want to do it probably either outside or in a room where you can vent the humid air out, because there is a lot that comes off of it. That's true. One question over here.
About how many gallons of algae do you think it would take to replace one of those houseplants?
So the question was, how many gallons of algae will it take to replace one of the houseplants? I think it'll probably take 5 to 10. Just eyeballing it, I would like to sit down and do the real numbers to figure that out, because we can measure, for example, like how much CO2 is usually exhaled by a human. We can try to extrapolate that out, but it shouldn't. My goal is to make this whole thing smaller than a house plant, and I think it's possible with like maybe 8 gallon tank. It's just a matter of optimizing it the right way. So my guess is we can do it with something not very big. But if we want to do more people, then we just make it bigger.
So you mentioned things are growing slowly. Do you have any idea what would be optimal or in current industry?
I think what would be optimal and what is close to optimal is once every few days. There's one paper I read where they could do it every 2 days. But what they did was they deliberately fed the algae tons of sugar to make it grow faster. And yeah, that works. And in the industry, they actually use different sugars to make the algae optimized for certain characteristics, like whether or not you want fatty or cellular walls, or whether or not you want more like organelles of a certain type. So I'm trying to think of how to answer this. Optimal, I think, depends on what you're doing. For me, optimal would be as often as I can, such that it would make the air in one room really clean, or in my apartment really clean. I think that winds up coming out to around once a week if I only want to filter CO2. If I want to just make it grow as fast as possible, I'll just feed it tons of sugar and then I can harvest every couple days, but it kind of defeats the point of the experiment, since I want as much carbon as possible to be coming from atmospheric air. One more question over here.
So I think just a thought, like people have aquariums in their house. Do you think aquarium is a reasonable jig to start with? Can the algae coexist with fish, or they are mutually exclusive? So have you researched that?
Yeah, so this algae is freshwater algae, so it won't grow in like a saltwater tank. Likewise, saltwater algae won't grow in a freshwater tank. For me, this was a tank that only had algae and nothing else. I'm not great at, I don't know a whole lot about like growing fish really to make sure they're really healthy and stuff. My understanding of that area is that algae is usually bad unless you have fish that keep it under control. So if you want to get started on doing something like this, my suggestion actually is to get, what's the name of it? There are these types of bottles that are about this big. They're like they're like a cup. And they're made of a plastic that allows like UV and infrared light through. And so you can experiment with growing algae in a small bottle to kind of play with the conditions. And then you can scale up from there. So if you're interested to get started, like there are totally kits you can order that just let you grow it in a small bottle to play with it. Because when algae grows too much, it can actually start affecting the chemistry of the water, and that can kill fish. And that's partly why a lot of people with fancy aquariums, like they hate having algae, because it's a really slippery slope between like one algae colony showing up and it being really out of control in your system. And sometimes the algae won't always harvest CO2. They can actually harvest O2 out of the water, which then creates oxygen starvation, and that can make the fish die. So it's actually kind of a balancing act if you're trying to make it coexist with other organisms. Question here.
Yeah, so I was just curious if you saw any difference in the growth rate for the algae. Was there like maybe when you seeded them, they grew really slowly, but then like after a certain stage, they like went to logarithmic growth or something?
Yeah, there's definitely, it's not, like the algae growth is not linear at all. Like when you're getting started, you have, let's say you have a 5-gallon tank, you maybe put in a gallon of water with a few cups worth of algae solution, and it's gonna be, the algae would be very sparsely distributed in that water, and they'll grow really slowly. And you don't really get logarithmic growth until the water is turning pretty green. And once the water is like kind of a really deep green, then they're growing really fast. And then that's where you're gonna maybe add, if you're in this example, you're gonna add water, they'll become more sparse again, the growth rate will slow, and then as it grows back, it'll go up, you add more water, and it's kind of like, it oscillates a lot because of how you're changing the conditions of the tank so dramatically. So if you wanna smooth that out, you probably need to be removing mixed medium while adding water at the same rate. And then you can probably stabilize the growth. Any other questions? Bueller? All right, thank you all so much for coming.